All right, so we've got first your measures of central tendency, mean, median, and mode. Okay, then we've got what are called measures of dispersion. And those measures of dispersion, your curriculum only focuses on 3. That is the range, which is the difference between the largest and the smallest value in the data set. If you had done data handling in grade 8 and 9, you would have made range already. Then you have got what's called the interquartile range. Now this one is different and it's a new one. The interquartile range is the difference between the upper quartile and the lower quartile. Okay, the acronym used for interquartile range is IQR. It's equal to Q3 minus Q1. Now, the interquartile range is very important in statistics, especially for your curriculum, because we use it to determine or to prove whether a data set has got outliers or not. And that's mainly for grade 11. Okay, so it's mainly for grade 11. Please. All right, so I was saying the interquartile range is the difference between the upper quartile and the lower quartile. But now the interquartile range it's a more effective measure of dispersion because it is not affected by extreme values or outliers. Okay, then we have got half the distance of the interquartile range. It's called the semi-interquartile range. Now the semi-interquartile range is not that important, but the one which you are going to encounter more is the interquartile range, Q3 minus Q1. Alright, now last week on Thursday I introduced the 5-number summary, which is made up of the minimum, the lower quartile Q1, the median Q2, the upper quartile Q3, and the maximum value. Now we need those 5-number summary to draw a graphical representation of the data set, okay, in terms of what's called the distribution of a data set, right? So we need those 5-number summary to draw a diagram, which is a graphical representation, and that diagram is called the Box-and-Whisker diagram. Now the Box-and-Whisker diagram, it's a major part of your curriculum because it comes up to metric. So it's introduced in grade 10, in grade 11 we talk about it as well, and then in grade 12 we write metric. Remember I told that, okay, I think it was the grade 11 actually. Now, but in your case you need to know that your grade 10 statistics is also tested in metric. So some metric papers, they bring the concepts on the Box-and-Whisker diagram, the 5-number summary and so on. So you still need to know these stats until metric. So with the Box-and-Whisker diagram, you have first your box, okay? This length here will represent Q1, which is your lower quartile. That is the median of the first half of the data set. Then that horizontal, so that vertical line will represent your Q2. Obviously, you have your number line. Okay, you can draw a Box-and-Whisker diagram only above a number line. I'm going to give you a nice worksheet just now where I put the number line for you so that you can draw the Box-and-Whisker by the end of the lesson. Can you stop? Okay. All right. So we've got Q1, which is the lower quartile. Then we've got Q2, which is the median. Then Q3, that's the median of the second half of the data set, if you arrange it in ascending order. Then we also have what are called whiskers. They are just horizontal lines drawn from the ends of the box. So we have got this whisker, the beginning of the whisker, that's where you find your minimum. Okay? And then this whisker here, you have got the end of that whisker, that will be the maximum value. So you have your minimum, your lower quartile, Q1, your median Q2, and your upper quartile Q3 plus your maximum value. Now on top of this Box-and-Whisker, you must have a below the box and whisker, you must have a number line. Now, when you write examinations, generally, we provide you with a grid. All right. So, I'll say, when you draw a box and whisker, it has to be on top of a number line. For examination purposes, we provide you with a grid or with a number line. Okay. Over the weekend, I finished setting your November paper, and you might see some of the things which I'm talking about now. That's why I'm being hard on some of it, because I'm the one who knows what's in your paper too. I'm the one who set it. I know what's coming in terms of the statistics. It's me who set it. Among all the 6 billion plus people on this planet, it's me who set it. In this country, there are almost 60 million people. It's me who set it. 1 over 60 million. Okay? So you need to take me serious. And I know there's some good children here. There are some learners in this class. Next year, they are going to go down from red 2, probably red 1 or blue next year in this class. So I don't want those children to be hindered. All right. So let's go over an example. Let's go over an example. Okay. So here we've got a question. I'm just gonna go over some of the things, how I got some of the answers. I used this with my grade 11 class, because this year we taught both grade 10 and 11 statistics. The concepts are the same. I don't need to worry myself to start something afresh when I've already have the same start. So the question says, the percentages achieved by a learner for a series of mathematics tests that he wrote throughout his grade 9 year are as follows. So you've got the marks there. Now, they are not in any order. They are just random. Right? Now, the first question says, calculate the 5-number summary. Okay. Now, if you've got this calculator, right, I'm going to repeat this. If you have this calculator, you won't need to stress. Within a few seconds, probably a minute, just enter all those values, and then you retrieve them from your calculator. Okay? So, doing this question here should take you about a minute or less. Okay? Now, what's your question?
All these numbers already.
It's not always that they will be known.
So in the test, are they?
I've answered you. Okay. So your 5-number summary, like in this case, the numbers are not arranged in any order, which means you have to rearrange them. Right? So I rearrange them here in the correct order. Okay, from the smallest to the largest. Okay, then what that means is the minimum is very easy to identify, so it's 28. The maximum is also easy to identify, it's 58. The quartiles now, those are the ones that can require you to do it manually, or you can use your calculator. Okay, so if we do it manually, because most of you don't have the correct calculator, and I hope that you take me serious, because next actually I would say in less than 2 months' time. Do you know that in probably less than 2 months' time you write your November papers? In less than 2 months' time. It's not very far. Today is the 19th of September. 19th of September. And I can assure you that it's most likely that your 2 maths papers, you write them before the 19th of November. It's most likely. I'm not sure about the dates yet, but it's most likely, which means you probably have less than 2 months. That's why you must not get into the mood for the holiday yet. You must get in the mood for the holiday after the November examinations. Okay, so your Q2, okay, remember I told you that if the data set is even, use the formula n over 2 to identify the first value in the middle of the data set. Then you take into account the second one. So n over 2 will give you 20 over 2, which is 10. Then you count. Now, this is the manual way. If the data set is not arranged in order, now it is arranged. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this is the 10th value in the data set. Since there are 20 of them, it means I also need the 11th value in the data set to calculate the what? The median. So I have to add 45 plus 47, then I will divide by 2, and you get 46. If you have the calculator will give you the value for the median, no stress. Right? Then, now, these two values, they divide the data set into two halves. But because we have got this 46, which is in between here, it means our first half of our data set will start from 28 all the way up to this 45. Okay? Starts from 28 all the way up to that 45. Our second half of the data set starts from 47 all the way up to 58. So again, we use n over 2, but now we are putting 10. So 10 over 2 will give you 5. Then you count now, 1, 2, 3, 4, 5. Then the sixth value, you add these two, divide by 2, you will get your Q1. Okay? Then Q3, we start counting from 47. So 1, 2, 3, 4, 5. So this value here and also that one. We add those two, we will get 52. So I got my 5 number summary. Now that's the manual way. Okay, that's the manual way. If the data is not arranged, you have to do it. You have to rearrange that data set. Okay, so I've got my 5 number summary. So I've answered that question. Okay, my 5 number summary: minimum 28, maximum 58, Q2 46, Q1 36, Q3 52. That's my 5 number summary. I need those 5 values in order for me to draw the Box-and-Whisker diagram. Why do you need a Box-and-Whisker diagram? So that we can analyze the distribution of the data set. I'll talk about data distribution just a minute. My advice to you is to I've got my number line there. Okay, so this is my number line. Now, in your case, as I said earlier, for an examination, we provide you with a nice number line. All right. I think I've got my box. Okay. So allow me to just start by drawing my box first. Okay, so I'm going to start with my Q1, which is 36, and my Q3 is 52. So 36 and 52. So 36 is somewhere here. So just allow me to approximate it. So 36 is somewhere there. Then 52 will be somewhere there. Okay, so that's my box. Right, let me just check. Yeah, it's fine. So then the median is 46. Okay, so 46 will be somewhere there. Okay. Then my minimum is 28. Now 28 is somewhere here. And then the maximum is 58. So 58 somewhere there. Okay. Then so we have got our minimum here. Then we have got Q1 and Q2, which is the median, and then Q3, which is the upper quarter, and then we've got the maximum. So this will be the box and whisker diagram for that data set. Yes.
So when you go into box and whisker diagram, you start from 0.
It doesn't necessarily have to start from 0. You have to look at the number 9. What you are carrying on, the values go on up to minus infinity. It's only that for the sake of the grid, sometimes it doesn't have to start from a value above 0. It doesn't have to show 0. Okay?
I started from the minimum and stopped at
Yeah, then you must indicate the errors. Yes. No, generally 2 marks or 3 maximum. It won't have lots of marks, but they are easy marks which you can easily score. Okay, generally we can give you marks for the quartiles and then the whiskers. That will be 2 marks.
3 quarters, 1 mark.
Okay. All 3 quarters 1 mark, and then the maximum and minimum, then you can have a second mark. Okay, the box and whisker, because we give you the number line, there's no mark for the scale and all that. So the main marks are just for drawing the box and those whiskers. That's it. So it will be about 2 marks. Okay, now just to carry on, I'm going to talk about the distribution of the data set. But before I move on, I need to answer more questions on the measures of dispersion. So C1 is the range. So the range is equal to the maximum minus the minimum, then you get 30. Okay? And then the interquartile range is going to be Q3 minus Q1. Okay? So we found our value for Q3, we found our value for Q1, 52 minus 36, that will give us 16. Okay, now the interquartile range will be 3 marks now. Because you need to find the value of Q3, you need to find the value of Q1. So you get 1 mark here, 1 mark here. Then the answer 1 mark. So if you're asked to calculate the interquartile range at this stage in grade 10, we'll allocate a question like that. We'll allocate it 3 marks. Okay? Because you have to find the quartiles first before you determine the interquartile range. Are you following? Huh? Okay. Okay. Is there anybody who has got a question before I move on to data distribution? Yes. 2 marks.
Yes. So are there any CA marks for page? So see what the wrong
Yeah, if you identify the minimum or the maximum incorrectly, you lose a mark here, but then you get a CA mark for the answer. So the interquartile range, the 52, that's an accuracy mark. The 36, which is the Q value of Q1, is also an accuracy mark. Hey, Mr. Ponda is not this side. Right? So the value for Q3 is an accuracy mark. Then the value for Q1 is also an accuracy mark. But the answer will be a CA mark. So you can get 2 out of 3, or you can get maybe 1 out of 3. But if you make a mistake for both the value of Q3 and Q1, we can penalize you, because the rule for CA marks is that you mustn't make 2 mistakes consecutive. Okay. Right, another question. Okay, if I take another question, then let's move to about this now. Then distribution of data. Now, this part here, it is mainly for the box and whisker diagram. after drawing the box and whisker diagram, you may be asked to comment on the distribution of that data. So there are three options. The first option is the data can be symmetrical. By symmetrical, we mean if you draw, okay, I'm going to start first by the box and whisker itself. Then I'll talk about the mean and the median. If you draw the box and whisker, if the data set is symmetrical, it means that the difference between Q2 and Q1 will be equal to the difference between Q3 and Q2. If the data set is what? Symmetrical. We don't worry about the whiskers. Okay? Then the best way of finding out whether the data set is really symmetrical is to calculate the mean of that data set. Then obviously determine the median Q2. If the mean and the median are equal, then the data set is considered to be symmetrical. So in most cases, you would have calculated the mean somewhere on top. That would be the first question. Then you probably would have determined the median somewhere after the mean. Then you can use those two values, compare them. If they are equal, then the data will be symmetrical. But that's not very common now. In real life, most data sets are not symmetrical. Okay? In real life, most data sets are not symmetrical. Those of you who are here on Friday, I showed you the box and whisker of the marks for the term. Okay? Now, it's not symmetrical. The mean and the median are not equal, but fortunately, the data is skewed to the right, which is a good thing. Okay, you should have copied this down. I sent this last week on Friday. Then, the data can also be skewed to the right, or we say it is positively skewed. If the data set is skewed to the right or if it's positively skewed, it means that the mean is greater than the median. So, before you do anything, check the value of your mean. If it's greater than the median, then the data is positively skewed or it is skewed to the right. Also, if you look at your box, or rather your box and whisker diagram, if the distance between Q2 and Q1 is shorter than Q3 and Q2, you can also conclude that the data is skewed to the right or it is positively skewed. But the basic criteria is that of the mean and the median. Okay, then the last one. The data can also be skewed to the left or it can be negatively skewed. In that case, your mean will be less than the median, or the distance between Q2 and Q1 will be longer than Q3 and Q2. When we say the data is negatively skewed or it is skewed to the left. Now, all this is part of a question which you may get asking you to comment on the distribution of the data set or comment on the skewness of the data set. So normally after the box and whisker, underneath it, you'll see a question. And that question will be asking you about this. Your answers must always be symmetrical, which is rare, positively skewed or skewed to the right, negatively skewed or skewed to the left. So if I go back to the example which I just did here, okay, If I go back to example, remember I calculated the mean, right? I calculated the mean. What was the value of the mean? Okay, no, I didn't calculate the mean here, right? But if we use the second criteria, the length between Q2 and Q1 is longer than Q2 and Q3. So this data here, it is negatively skewed. Or you can say it is skewed to the left. Okay. Okay. So make sure you're aware of it. So I think I'm done for today. Then I'm going to give you a class exercise just now.